Earth is a blue world, a planet where water dominates everything. 70% of the surface is covered by oceans. Clouds are always forming, always raining, always evaporating again. To us, water feels infinite, familiar, even boring. We drink it, we boil it, we swim in it, we build our life around it. But here is the strange and silent mystery people rarely think about. How did all that water get here? We wake up every day under a sky full of moisture. We look at the horizon and see the ocean. We think this is normal. But the universe is mostly dry. Most planets we know are dry. Most moons are dry. Even the sun's neighborhood is not a place where liquid water should naturally collect. So why is Earth blue? Where did Earth's water come from? Tonight, let's slow down, relax, and follow this mystery. Take a deep breath. Close your eyes if you want, because the beginning of water is older than the beginning of Earth itself. Before Earth existed, before the sun formed, before any planet was even imagined, the universe had already created hydrogen. Hydrogen was born just minutes after the Big Bang. It filled space everywhere. Later, giant stars lived, grew old, and died violently in supernova explosions. In those final moments, oxygen atoms were forged. And with hydrogen and oxygen together, water could form in cold, dark space. Tiny water molecules drifted between stars, inside the interstellar clouds. They froze onto microscopic dust grains. Whole regions of space were filled with delicate ice. This means something almost poetic. Water is older than Earth. Water is older than the sun. Water is older than everything in the solar system. Our oceans are built from a chemistry that began before our planet ever existed. When a new star system begins forming, it starts as a giant cloud of gas and dust. Inside that cloud, there are frozen molecules of water, trapped like glass inside grains of dust. So when the solar system was young and still a swirling disk of dust, ice was already there. Earth as a planet formed by collecting dust and rocks and metals. And along with all that, Earth collected some of that ancient cosmic ice. Imagine this. Every drop of water on Earth once floated frozen in deep interstellar space, long before Earth existed. Your drinking water, the water in your blood, could have formed before the sun even started shining. That is how deep and old the story of water is. When Earth was just beginning to form, it wasn't calm, it wasn't blue, it wasn't gentle. The early solar system was chaos. Thousands of rocky bodies were slamming into each other. Temperatures were so extreme that any water at Earth's orbit would instantly boil and escape into space. So Earth, logically, should have been born dry. Imagine Earth in its first moments, just a glowing, molten sphere. Lava everywhere. No oceans, no rain, no clouds, just fire. So again, the mystery becomes deeper. If Earth started as a fire planet, how did it end up as a water planet? Our planet was born inside the inner solar system, the region close to the sun. This area is far too warm for ice to survive. In the outer solar system, far away, near Jupiter and beyond, ice was stable. But Earth was born in the wrong place to have water. So the truth becomes uncomfortable. Earth was born in the wrong zone to have oceans. But somehow, it still has oceans. So we start to suspect maybe Earth's water was delivered later. maybe water came from the outside. That idea is the key to the entire mystery. To figure out where the water came from, scientists found a genius method. Water molecules on Earth have a specific pattern inside them. Some hydrogen atoms in water are heavy. They contain an extra neutron. We call this heavy hydrogen deuterium. By measuring the ratio between normal hydrogen and deuterium, the DH ratio, we can identify where the water originally came from. It's like a chemical fingerprint. Every source of water in the solar system, comets, asteroids, planetary bodies, has a different DH ratio. So, if we find a space object whose DH ratio matches Earth's oceans, we have found one of Earth's true water suppliers, like matching DNA. This is how we trace the origin. When scientists measured water trapped inside certain carbon-rich asteroids, the DH ratio was almost identical to the water in our oceans. This was a breakthrough, because comets, which people used to blame, actually have the wrong ratio. Most comets contain too much deuterium, so they are not the main source. Asteroids, not comets, match Earth's water signature. This strongly supports the idea that a giant population of asteroids impacted Earth early and delivered frozen water locked in their minerals. Around 4.1 to 3.8 billion years ago, the inner solar system entered a period we call the Late Heavy Bombardment. Millions of rocky bodies smashed into Earth, the Moon, Venus, and Mars. Each impact could bring water. If this continued for hundreds of millions of years, you get enough water to fill oceans. This means oceans might not be an accident. They might be the result of a long, violent delivery system. Scientists found ancient zircon crystals from Western Australia. Inside them is chemical evidence that liquid water existed already 4.3 billion years ago. That is extremely early in Earth's timeline, so oceans formed very soon after Earth's crust cooled. This is surprising. Earth did not wait billions of years to get water. It got water rapidly, near the beginning. Not all water has to come from space. Deep inside the mantle, hydrogen and oxygen can combine under intense heat and pressure to form new water molecules. Some mineral crystals found in deep volcanic rocks contain trapped water. Their chemistry suggests Earth is producing water internally. So the origin of Earth's water is not one source. It is a combination. Primordial ice inherited from space, asteroidal delivery during bombardment, and internal mantle water generation. All three mechanisms play a role in making Earth a water planet. So by the time Earth finished its chaotic early formation, and before life could begin, Earth already had oceans. And those oceans came from cosmic chemistry far older than Earth itself. Not how water arrived, but how much water does Earth actually have? And how did that water stay liquid for billions of years? Because having water is one thing. Maintaining it for 4 billion years is another challenge. Let's continue. We live on a surface where water dominates the view, but on a planetary scale, Earth is not a water world. Ocean depth is tiny compared to Earth's diameter. If we shrank Earth to the size of a billiard ball, every ocean would be nothing more than a thin layer of dew. So even though oceans look endless, the total amount of water on Earth is surprisingly small. This means Earth did not need infinite asteroids to create oceans. It only needed the right delivery and the right preservation condition. Earth should have lost its oceans multiple times. Solar radiation tries to strip water away. Volcanoes could have boiled it. Freezing global ice ages could have locked it away. But Earth got extremely lucky. Earth has the right atmospheric pressure, the right surface temperature range, the right greenhouse balance, and crucially, the right distance from the sun. Earth is in the habitable zone, not too hot, not too cold, just the correct energy to keep water liquid. Liquid water survived because Earth sat in precisely the right orbital slot. To understand how fragile water is, look at Venus. Venus might have had oceans once, but Venus is just slightly closer to the sun, enough to trigger a runaway greenhouse. The oceans boiled, water vapor rose to the upper atmosphere, solar radiation split the molecules, hydrogen escaped into space. Water was erased from Venus. This is what could have happened to Earth. Earth avoided it by a small margin. Another protection, Earth's magnetic field. The magnetic field blocks solar wind. Solar wind can strip away atmospheric gases, including water vapor. Mars lost its magnetic field. Mars lost most of its atmosphere. Mars lost most of its water. Earth kept its magnetic shield, so Earth kept its oceans. Water is not static. Water on Earth is constantly recycled. Volcanoes release water vapor from deep mantle sources. Subduction zones drag water minerals back inside the Earth. It is a continuous exchange. Earth is breathing water through geology. The ocean on the surface is only one layer of Earth's water system. There is more water locked in minerals deep below the crust. Some scientists estimate that the deep mantle holds multiple times the amount of water in all surface oceans combined. This is not liquid ocean water, but chemically it is water. Earth is not just a surface water planet, it is a water-storing planet. Earth has oceans because of cosmic chemistry. Earth kept oceans because it sits in the narrow safe zone. And Earth maintains oceans because our planet is constantly cycling water inside itself. This combination makes Earth extremely rare. A planet that should have been dry, but instead became blue. The oceans feel eternal, but this blue era is not forever. Water can be destroyed. Water can escape. Water can be locked away. And slowly, the oceans will not last. Water is made of hydrogen and oxygen. Hydrogen is extremely light. At the top of our atmosphere, some hydrogen atoms escaped to space. We can measure that loss today with modern satellites. It is slow, but it is real. Every second, tiny amounts of water are leaving Earth forever. It is a silent leak, invisible, constant. At the same time, water is also being locked away underground. Subduction zones push ocean floor minerals down deep into the mantle. When oceanic plates sink, they carry water inside them. Much of that water never comes back to the surface. Over hundreds of millions of years, this also reduces ocean volume. So water is not stable. It moves outward to space and inward into the mantle. Earth's oceans are temporary. This is the biggest factor. The sun is slowly growing more luminous as it ages. It is very subtle right now, but in about 1 billion years, the sun's brightness will increase enough to heat Earth's surface significantly. More evaporation, more water vapor in the atmosphere, more greenhouse trapping. This feedback loop will eventually make Earth hotter than it can control. Once the cycle begins, the final stages happen quickly in geological time. As temperature rises, oceans evaporate, atmosphere thickens with steam, hydrogen loss accelerates dramatically. This is exactly what happened to Venus. Earth will follow the same pattern in the far future. Eventually, all liquid oceans will disappear. Earth will become a desert world. Rock, dust, heat. The blue color will vanish. Clouds will disappear. Life as we know it will not survive. This is the natural end of water on Earth. When we look at the ocean today, we are watching something extremely rare in cosmic history. There is only a small window in Earth's timeline where oceans exist. Before this era, Earth was too hot. After this era, Earth will be too hot again. We are living inside this limited, temporary sweet spot. A short, unique moment where Earth is blue. So when you look at water, in a cup, in rain, in the ocean, remember, Earth did not begin with water. Earth will not end with water. Water is only passing through. The oceans exist because the timing of the universe allowed it. And for now, we are fortunate enough to live inside that brief, miraculous blue moment.